Good day. Hope that you're doing well. Now, continuing with the video, we're going to be looking into question 8. Now, under question 8, we're going to be looking into Euclidean geometry. Now, remember your Euclidean geometry is divided into two parts, right? The first part being your grade 11, whereby you're going to use circle theorems as well as some of the knowledge you have with regards to parallel lines, right, to solve for certain angles. And now the second part of your Euclidean is whereby you're going to be making use of your proportionalities, your triangles, right? But now let us start off with this first question and let us interpret the information that we're given. So now here on the circle, the diagram below, okay, AO is the center of the circle. Now, okay, ABC are points of the circle, and now they've told me that, okay, I have a tangent which is BC, right? BC is my tangent. All right, they've given me angle BDC as 22.5. All right, now they also told me that CD, right? So let me highlight those two lines so that you could see them. So CD, it's equals to BD. So these two lines are equal to one another. So as a result, can you see that triangle CDB, right, which is this triangle here, it is an isosceles triangle. And remember, what do we know about base angles of an isosceles? They're going to be equal to one another. So as a result, I know that this angle C here, it's also going to be equals to 22.5, right? But now let us see what this question is requiring from us. So now the first question wants me to find A1, which is this angle right over here. So I am given a tangent. Every time, whenever you are given a tangent, the first thing that should come into your mind, right, is your tan chord. And also, let me just give you another clue with regards to why would you be able to think of a tan chord in this situation. Now, let me just quickly zoom out. Now, let's have a look at this diagram. The angle that we are given, it is between my chord, this is a chord, and this is a tangent, right? I'm given an angle between a chord as well as a tangent. So this is not straight, so let me just do this. So I'm given an angle between a chord as well as a tangent, right? So this would give me a clue that I need to apply tan chord. Now, how do I go about applying tan chord? So how I apply tan chord, it's this Z right over here, right? So for example, if this is the angle between a chord as well as a tangent, it will be equals to that angle. So this angle would be equals to this, right? So do not confuse it with alternating angles, which are like that. No, in this instance, I'm saying that this here is going to be equals to that, right? So let me just quickly show you in a triangle inside a circle. So if I could draw a circle here, I could draw a triangle and say this is my tangent. And I'm saying that the angle between a tangent, let me just reduce the size of that. So the angle between, this is a tangent, this is a chord, right? So drawing the Z, it will go from here. So this would be my Z, and it would go here, and it would go here. And I'm saying that this here is going to be equals to that, right? These two angles are going to be equal. Tan chord theorem. So now, let me try and apply that here in this scenario, right? So let me erase these lines so that I could draw that. So here, this is my chord, this is my tangent, right? So, and then the Z would extend, would go down there, right? And as mentioned, this is going to be equals to that, right? So let me just redraw this here so that you could see it. This here is going to be equals to that, right? So as a result, A1 is going to be equals to 22.5, and my result is tan chord theorem, right? Obviously, there are many ways in which you can go about identifying tan chord. This is just the technique that I use, right? So let me just quickly write down the values that I've already found. I know that my A1, it will be equals to 22.5. Now, what about D1? So let's look at D1. So with D1, all right, here's D1, right? I need to go about finding that angle that is equals to D1. Now, remember, let's see D1. How would I go about finding D1? So firstly, let me see. I have D1. Remember, I said this is also going to be 22.5. And if you could have a look at D1, right? D1 is an exterior angle of a triangle. So let me just try and redraw this triangle I'm talking about. So let me just try and redraw it here. So here I have angle C, I have angle B, I have angle D, and this is D1, right? D1 is an exterior angle of a triangle, and as mentioned, or rather, as you now know that an exterior angle of a triangle is equal to two opposite interior angle, right? The sum of two opposite interior angle. So as a result, I know that D1 would be equal to this angle C as well as this angle B, right? Now, let me go about writing that. So D1, so firstly, I'm going to start by saying that angle C is equal to 22.5, right? Because I mentioned that triangle, so let me mention my triangle. In triangle CDB, right? I said this is an isosceles triangle, right? So angles opposite equal sides. Angles opposite equal side, right? So I've mentioned that angle C is equals to 22.5, and I'm going to mention that D1 is going to be equals to angle C plus angle B. Why? This is an exterior angle of a triangle. As a result, D1 is going to be equals to 22.5 plus 22.5, which is, let me just put this would be equals to 45 degrees. So D1 is equals to 45. Now, let us see what other angle do we need to identify, B2. So now let's see how can I go about finding B2. So I can see that where B2 is situated, I have my tangent. Now remember, there are three principles that you need to always remember whenever you are given a tangent, but mostly you're going to be making use of these two, right? The first one being your tan chord, which we just went through, and the other one it is that concept that says that your line from center to tangent, right? It would meet with your tangent at 90 degrees. So this is my tangent. Let me highlight my tangent, CB, right? It was given as a tangent, and my line from center O to circumference is OB. Now, I said this is 90 degrees, right? So this is the first thing that I'm going to mention, right? So let me just quickly raise you on the side. So I'm going to mention that angle B, so I have B2, angle B2, which is this angle, as well as this angle. What is that angle that it was given as 22.5? DBC plus DBC. This would be equals to 90 degrees, right? And my reason would be tan perpendicular to radian, right? So I'm trying to solve for my B2, remember, and my DBC was given as 22.5. This is equals to 90. So as a result, B2 would be equals to 90 minus 22.5, right? And this would be equals to 67.5. So let me erase here so that I could write that here. So B2 is 67.5. Now O1. O1, every time whenever you solve it for an angle that is associated with your center, always remember that principle which states that angle at center is going to be 2 times the angle at circumference, right? So the most common shape that you are used to with regard to this theorem, it is that one whereby you are given something like this, right? Whereby this angle here at center is going to be 2 times this angle at circumference, right? Right. Now, another one that most students tend to forget, or like most of the time they do not pay attention to it. So let me just erase here. It is this one that we're given here on the diagram, whereby you're given something like this. So let me just do this. Okay, let's say this touches the circumference, but let's say this is your center, right? So here, in accordance to this theorem, we're saying that this angle at center here is going to be 2 times this angle at circumference, right? So it's similar to your angles in the same segment, right? So here, as you can see, we have O1, which is in the center. This is going to be 2 times the angle at circumference, which is D1, right? So now, remember, this angle needs to be at the center. This needs to be at the circumference of the circle, right, for this to be applicable. So here, I would start by mentioning that if I take O, so O1 is going to be 2 times angle D1, and my reason would be angle at center it's supposed to be 2 times the angular circumference, circumference, right? As a result, remember D1, it's 45, so O1 would be equals to 45 times 2, which is equals to 90 degrees. Now, prove, given reasons, that OA it's parallel to CB. Now, let me highlight those lines, right? The line from O to A, this is parallel to the line from C to B, right? So I need to prove that these two lines, they are parallel to one another, right? So let me go about analyzing what I have here. So remember, there are three ways you could prove parallel lines, right? So the first one being your corresponding angles. If you could prove that this angle is equal to that angle, right? Rather not, so sorry, I made a mistake. So if you could prove that this angle is equal to this angle below, therefore these two lines are going to be parallel, right? The other one is your co-interior. If you could prove that this angle plus this angle, adding them together, you're going to get a 180. These two lines are going to be parallel. And the last one being your alternating angles, proving that this angle would be equal to that angle, therefore these two lines are going to be parallel to one another. So here the first shape I can identify is my Z shape. You can see, right? And this here, it's 90. And then adding these two angles here, remember I said angle at center, right? So the line from center OB, it's going to meet with your tangent, which is CB at 90 degrees, right? So O1, it's 90 degrees, and B2 plus angle DBC, it's also equals to 90, right? I have this Z shape here, so let me just, this is 90 as well as these two angles added together are 90. And as a result, this simply means that these two lines are going to be parallel to one another, right? So therefore, CB is going to be parallel to OA, right? And my reason, what would it be, right? Alternating angles, right, equal. These two alternating angles, which are 90 degrees, they are equal to one another, all right? And that will be all for that question. Now let us go do the other questions. So remember, this is 90, and I've proved that these two lines are parallel, just in case I'm going to use them. Now let us see what the other information requires from us. If it is further given that the radius of the circle is 12 units, now radii, it is the line from center to circumference. So basically this line, if it's given that this line is 12 units, what is it that I need to calculate now? Calculate the length of BC. So where is BC? Now I want you to note something here, right? I want you to note something. If you could look into the big triangle, what rectangle am I referring to? Triangle CBA, right? Remember, we tried to find the length of CB, but these here are equal, these two angles. So do you agree that these two lines are also going to be equal to one another? All right, so let me just redraw the big triangle here so that you could see what I'm referring to. This is B, this is A1, and this is angle C. And these two are 22,5. 22,5. And because these two are equal, therefore, these two lines are going to be equal to one another. Do you see that? These two lines are going to be equal to one another. Now, here, if you could look into this triangle here, the right angle triangle that we have here. So let me just, do you see that the other right angle triangle that we have there at the top, right? Remember, this is 90 degrees. And they've told us that the line from center to circumference, which is your radii, OA is also a radii. It's 12 units, right? So if I were to draw the right angle triangle there, this is the line from O to A, which is 12 units. And I also have a line from, this is O to A, this is O to B, which is also 12 units. They are both radiuses, right? I'm trying to determine this line. Why? Remember, BA, it is equals to BC, meaning that if I could find the length of BA, I would be able to automatically find the length from B to C, right? So now this is 90 degrees, right? And remember, in a right angle triangle, whenever you're trying to solve for a side, what is it that you're going to use? The theorem of Pythagoras. Now, this line is opposite to 90 degrees, meaning that this would be my hypotenuse, right? So r squared is equals to x squared plus y squared. So my value of r, square root of x squared, 12 squared, plus y squared, which is 12 squared. This would be equals to, so let me just punch that into my calculator, 16,97 rounding off to two decimal places, right? So the length from B to A is 16,97. And remember, we said BA, so this is 16,97. We said BA is going to be equals to CB. And why is that? It's because of these two angles are equal, right? This would also be 16,97, right? So in a nutshell, this or that will be the length of BC that they required us to calculate. So firstly, you're going to mention that, for example, OB is going to be equals to OA, and they're both going to be equals to 12 units. They are radii, right? And as a result, so you're mentioning that these two lines are radii, and also you're going to mention that CA or CB is going to be equals to BA. Why is that? Because their base angles are equal, right? So opposite equal base angles. That would be your reason, right? And from there, you're gonna do these steps that I've just done right over here, right? So try to do these questions on your own. And remember, whenever you have any questions, always feel free to reach out.